plus AZ equal to B.
Okay, so AZ square plus BZ is some complex number, right?
Yes, sir.
Some complex number. Similarly, BZ square plus AZ is also some other complex number. Okay. If we
Okay,
assume
sir.
Z as x plus iy, what is z square? Z square should be yes, x square minus y square, right?
Yes, sir.
Okay, AZ square plus BZ would be this, right?
Sir.
Agreed. AZ square real of AZ square plus BZ.
Yes, sir.
Right, that should be this one only, no?
Yes,
This
sir.
will be equals to A, right? Similarly, real of BZ square plus AZ, right? What should that be? B into x square minus y square plus A into x, right? That should be equal to B, right? We have got two equations, right?
Sir,
Okay.
how is A? Sir, AZ అనేది AX ఎలా అవుతుంది, sir?
What?
Sir, how does
Wait.
AZ?
So here it is real of BZ square plus AZ. Okay, first look here. This means what? AZ square A into Z square, right? What is Z square?
Z square
Z
X
square.
square minus.
That Z square is x square minus y square plus 2xy into I, right?
Yes, sir.
Agreed. Plus b into x plus iy, right? Agreed,
Yes,
no?
sir.
But we have to take only the real part. What is real part? A into x square minus y square plus b into x. On agreement.
Yes, sir.
Real part of this is a into x square minus y square plus b into x. That should be equal to a. Similarly,
Okay.
real part of this is equal to b. So these are two equations, right?
Yes, sir.
Okay. 1 second. Hello. Yes, ma'am. This one.
Yes, sir.
Okay. So we have got two different equations. Okay. Now what is our goal? Number of elements, number of such z's, right? Basically, number of such combinations of x and y. That's what we want, right? Basically,
Yes, sir.
we are trying to figure out if there is some condition on x and y. So, for example, x should be less than 2, y should be greater than 1, whatever, something like that, right? We have
Okay, sir.
these two conditions. In these two conditions, a and b have to be real. Is there any condition? Is there any restriction on x and y? Is what we have to explore, right? Some restriction on x and y, right? So what we do using these conditions, we have to get some restrictions on x and y. So we subtract one from the other and we are left with this. Agree?
Yes, sir.
Okay. But this is not any great condition, right? We have infinitely many values of x and y. That will satisfy this condition.
Yes, sir.
Agree? Agree. So that means this one has got infinitely many solutions and there is some options are actually a little something wrong here. Okay, ma?
Okay, sir.
Understood. Clear, no? So whatever this condition that he has given, we are trying to express some condition on x and y. Okay?
Yes, sir.
Agreed, no?
Agreed.
Okay. Next. This one, see. This is some z by some z. Okay?
Sir,
Tell me.
so how do we solve the previous question, sir? So what option do we select?
Which one? This option is not there actually. this question they would have given marks for everyone. There is a mistake in the question actually. This one only, no? Hello. Hello.
హలో సార్.
హలో వినపడుతుందా?
సార్ ఇప్పుడు వినిపిస్తుంది సార్.
ఓకే ఓకే. So this question the options are wrong. So they would have given marks for everyone in this question. Okay.
ఓకే సార్.
Okay. This one, see, this one there is some z by some z. Okay. Right. Some
Yes,
z1
yes.
by z2. You would have done this in IP questions, right? Exercise 1B, I think this question was there. Right now?
Yes, sir.
Okay. So what is the goal here? Z1 by z2 you will convert to z3. Right. A plus IB kind of format. Okay. So you will multiply the denominator with its conjugate. Okay.
Sir, we do it like rationalization, sir.
Right. So there's a typo here. It should be 1 plus I sin theta. Right. And then in the numerator, you will pick up the real part and equate it to 0. What is the real part here? 1 into 1 and 2I sin theta into I sin theta. Right. So that means 1 minus 2I square. 1 plus 2I square sin square theta, which is nothing but 1 minus 2 sin square theta. So sin theta should be equal to. Okay. What is the general solution? Here, tell me. What all values of theta is applicable? This one.
Sir,
This one. This one now tell me what all values of theta. Sin theta equals to sin square theta equals to half. Sin theta equals to 1 by root 2. What all values of theta are applicable between 0 and 2 pi? Hello.
sir, yes, sir.
Audible, ma?
Audible, sir.
Okay, tell me. This one you know, no trigonometric equations.
Sir, I know like how to do general solution and all, sir, but
Okay,
I
tell
don't
me
know
what
this.
is general solution here?
Sir, there's no equation given, so how can we find the general solution, sir?
No, this is the equation, no? Sin theta equals to 1 by root 2, let's say. Okay, tell me for this sin theta equals to 1 by root 2. What is the general solution?
Theta belongs to theta equal to
Hmm.
45 degrees, sir.
What is the next one? What else? 45, 135 also, no?
Yes, sir.
Okay. So sin theta equals to plus or minus 1 by root 2. So what does that mean? That means this angle, this 45, this 45, this 45, and this 45. All are valid, right?
Yes, sir.
Plus or minus 1 by root 2. What does that mean? N pi plus or minus pi by 4. Okay.
Okay, sir.
Okay, this is the general solution. But he is asking between 0 and 2 pi. That means pi by 4, pi minus pi by 4, that is 3 pi by 4, 5 pi by 4, and 7 pi by 4. Okay?
Yes, sir.
Okay, 5 by 4, 3 pi by 4, so 5 pi by 4, 7 pi by 4, you add all of this, you'll get 4 pi. Agree, ma?
Understood, sir.
Easy only, na?
Yes, sir.
Okay, next. There is a complex number such that this is purely imaginary. Okay?
Yes, sir.
Okay, this is purely imaginary means real part should be equal to 0, right? And he is given another condition x plus y square equals to 0, then what will happen to this? Okay, if you put z as x plus iy, this is some complex by some complex, right?
Yes,
Some
sir.
complex by some complex. Again, we will multiply its conjugate to get into a plus ib format, right?
Yes, sir.
Okay, now in this, what is saying? This is purely imaginary. So that means real part should be 0. What is real part? 2x into 2x. and this thing into this thing, right?
Yes, sir.
4x square plus this thing into this thing. I square equals to -1. This minus will become +1, right?
Yes.
So if you simplify this, okay, there is this here you got one equation, right?
Yes, sir.
Here you got one equation, and you have given one more equation, x plus y square equals to 0, right? Using these two, you are actually able to get this relation. Got it?
Yes, sir.
Okay, try this once. You should get answer as 3 by 4. Okay, we are not doing anything spectacular here. What exactly we are doing? We are taking z equal to x plus iv and just substituting and using the same condition, we are deriving this. Okay, ma?
Yes, sir. Sir, got it, sir.
Got it now? Okay, very good. Fantastic. Look here. Again, similar problem. Okay, see, I think almost same. 2z minus 3i by 4z plus 2i. This is a real number, right? That means you will
Yes,
get
sir.
some condition similar to this, right? And which of
Yes,
the
sir.
following is not correct? Okay, you need to pick, you need to figure out what exactly is the condition and then which is not satisfying, right? So, is multiplying, okay, this part you understood, no?
Yes, sir.
Okay, if this is completely real, right? What does that mean? 2x into 4x plus this into this, that should be equal to, uh,
Zero.
right? It is completely real number. This is a real number, right?
Yes, sir.
Real number means this into this imaginary part should be 0, right? 2x into this one and 2y minus 3 into 4x. That should be equal to 0, right?
Yes, sir.
Imaginary part should be equal to 0. Okay. Now this one is equals to 0, right?
Yes, sir.
That means either x equals to 0, you can simplify this. Either x equals to 0 or y should not be equal to minus 2, right? Minus half. Understood, no?
Yes, sir.
Agree, no?
Agreed, sir.
Okay. So that's what. So this one is actually wrong. Okay? Because
Okay,
here he is saying y should be equals to minus half. See what is wrong with this? If you assume y equals to minus half, then this itself will break. Okay.
yes, sir.
Y equal to minus half is clearly not possible. Okay, ma?
Okay, sir.
Okay. So y equals to minus half is not possible here. Okay. Cool. Uh,
Sir, I don't know functions properly, sir. So, how should I learn functions, sir? When will you teach it, sir?
functions. Okay. Okay. Um, okay. So then I can teach anytime, but I think you should decide because you have these things. Your exams are going on. No. If you are fine, then we can take up functions after this.
Okay, sir.
Okay. Then your exams, your college exams, you'll handle yourself. No. Then
Sir,
we'll
my
not.
college exams are behind us, sir.
Behind us means.
Sir, like circles and quadratic equations were completed long time ago, sir.
Oh, okay, okay. So we need not worry about your college exams, no then.
Yes, sir.
Okay,
Next
okay. Then
exam will be on sequence and series and cumulative, sir.
next is sequence and series cumulative. So that is also not a worry, right?
Yes, sir.
Sequence and series we did, we
We
did
did it, sir.
we did it, huh?
Yes, sir.
Okay, okay. So sequence and series, then after this complex numbers, no?
Yes, sir.
Okay, okay, okay. And this week what is happening now in school, in college?
Sir, on Monday they will start De Moivre's theorem, sir.
Okay, complex numbers only. That is second chapter, no?
Yes, sir.
Okay, okay, okay. Complex numbers. Okay, okay. That also we will touch. Okay. So then, cool. So today we are doing some previous year questions. No, you will get some confidence. Then you will be able to do some more. Okay.
Okay, sir.
So these are not looking difficult. Huh? Are they looking
Not
difficult?
not difficult, sir.
Not difficult. Huh? I have picked only 2023 and 2024 questions.
Yes, sir.
Okay, these are the recent ones only. Okay, but earlier year questions also more or less similar. They are not difficult. You just need to know the trick. That's it. If you know the trick, they are not difficult. Okay.
Yes, sir.
Okay. Cool. Then after this, we can pick functions then. But functions they will not cover again, no, in our college. I think they would have done in first year.
Sir, they will cover after completion of second year syllabus, sir.
After completion of second year syllabus, they will complete it by August 10,
August 30th, sir.
August 30th. Okay. Cool. 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 After that, I think they will do revision of entire syllabus. No?
Yes, sir.
Okay. Okay. Cool. Cool. Then after this, we'll pick them.
Okay, sir.
Okay. Cool. Okay. Read this. A
For
belongs to
A,
complex number. Okay.
for
A is
A
a
belongs
complex number.
to complex number.
Uh,
Let A equal to
this
Z
capital A is a
belong.
set. This capital is set of Z, not A. Okay. Z is another
Okay.
complex number. Okay.
Yes, sir.
Such that real of A plus Z complement is greater than imaginary of A dash plus Z, whatever. So, and see, similarly, B also some condition. Right?
Sir, A dash is like Z complement only, sir.
Z complement, let's say. So you assume A has something. Say, for example, he has assumed x1 plus iy1. Okay. Similarly,
Yes,
Z
sir.
he has assumed some other complex number, right? Then he is expressing this statement in this format. A plus Z complement. What is that? Real of A plus Z complement is x1 plus x, right? And
Yes, sir.
imaginary of A complement, that is minus y1 plus y, right?
Yes, sir.
There is a typo here. This should be minus y1. Okay.
Okay.
Minus y1 plus y. So this is greater than this. That is, this condition is what he is saying. Similarly, for the other condition. Okay. Similarly, there is this condition. This condition, if you write it like this, you will get something like this. Okay. So you got one condition this, another condition is this. Okay. Now, what is he saying?
Find out, sir.
Okay. So there is x1, y1, there is x and y. X1, y1 belongs to A, x and y belongs to z, right? Now, what
Yes,
is
sir.
saying? If this condition has to be satisfied, okay, set A contains all the real numbers. Okay,
Sir,
understood.
here, ఏ- సార్ ఏకి ఏమైతే ఇచ్చారో బికి కూడా అదే ఇచ్చారు కదా సార్.
No, no,
కానీ
no.
సైజ్
This is less than, that is greater than. That's it.
ఎస్ సార్.
Okay, this is less than, that
ఏ
is greater
కూడా
than.
ఓకే
Okay,
సార్.
now what is he saying? If real of A and imaginary of A are both greater than 0, okay, then the set A contains all real numbers only. So what is he trying to say is, let's say if real of A, imaginary of A is greater than 0. So for example, if A is something like this complex number, this one is something like 2 plus 3i. Okay? Real
ఎస్
is
సార్.
greater than 0, imaginary is greater than 0. If this is the case, then Z will have all such complex numbers with only real numbers. That means this Y should always be 0. That's what he is trying to say. Right?
ఎస్ సార్.
Okay, if the x1 and y1 are greater than 0, then y definitely should be equal to 0. Right?
Yes, sir.
Okay, why definition? So then it is very easy to find out some other counter example where in the case y is not equal to 0 even when this and this are positive, right? So for example, in this case only, right? So you can always, let's say 2 and y1 is minus 3, right? 2 plus x greater than minus 3 plus y. You can always fit some x and some y, right?
Yes, sir.
So for example, 10 and 1. You can always fit it like this, right? X is 10, y is 1, right? It need not satisfy this condition, right?
Yes, sir.
Set A contains all. Okay.
Yes, sir.
Okay, ma?
Okay, sir.
And he's saying set A contains all real numbers. Understood,
Yes,
no?
sir.
So you
Understood, sir.
can it's very easy to find out some counter example. So for example, you can also find out some cases where some real numbers are missing from set 1. Okay?
Okay, sir.
You can find out a case where certain real numbers are actually missing. Right. So
Okay,
for
sir.
example, if you put y equals to 0, right? If you put
Yes,
this
sir.
this one y equals to 0, right? What does that mean? 2 plus x is greater than minus 3. That means there is some restriction on x, right?
Yes, sir.
Okay. There is some restriction on x. You cannot get all real numbers also. Okay, ma?
Okay, sir.
Understood. So using these two restrictions, you have to figure out what is true, what is not true. Okay?
Okay, sir.
Okay. Now here again, z belongs to C and z complement, right, is equals to z conjugate is equals to I into z square plus real of z conjugate, right? Very easy again. So left hand side you have some x plus iy, right hand side also you have some x plus iy. Real equals to real, imaginary equals to imaginary, two equations, two unknowns. Okay?
Yes, sir.
Okay, two equations, two unknowns only, right? Everything is in the form of x plus iy, right? Z complement is x minus iy. This equals to I into z square minus I square plus 2xyi. And real of z conjugate is obviously x. Okay, compare real, real, imaginary, imaginary. You got two equations, solve both of them. Okay?
Okay, sir.
Okay, you are getting, I think, x equals to 0, y equals to minus of, and x equals to 0, y equals to 0 and 1. Okay?
Yes, sir.
Understood now?
Sir, can you explain that one?
Okay,
Uh,
okay.
about steps.
This one. So we have to solve these two equations, right?
Yes, sir.
x equals to minus 2xy. Okay? So this
Yes,
is
sir.
valid when x equals to 0, right?
Y equal to
So if you are, if irrespective of y could be anything, right? When x equals to 0, this is valid, right?
Yes, sir.
Okay, when x equals to 0, y could be anything, right? Okay.
Yes, sir.
Y as per this, y could be anything. Y could be 10, 100,000, doesn't matter. When x equals to 0, this is always valid. And then if you replace here x with 0, then we'll get minus y equals to minus y square, right? That means y equals to y square, right? That means y is either 0 or 1. Agreed? When x
Agreed, sir.
equals to 0. So that is what he's trying to say. Okay?
Okay, sir.
Okay. When x is not equal to 0, what will happen? X equals to minus 2xy. Right? Then this x and this x we can cancel. Y becomes minus half, right?
Yes, sir.
Okay, now y becomes minus half. That means this is half equals to minus 1 by 4 plus x square plus x, right? This equation is only in terms of x now. Because y you
Yes,
can
sir.
replace with minus half, right? This and this you replace, then you get a quadratic equation in x, right? When
Yes,
y
sir.
equals to minus half, we are getting two values of x. Okay, so basically what we are getting, x equals to 0, y equals to minus half, that is 0 minus half I. Sorry, so when x equals to 0, we are getting y equals to 0, that is 0 plus 0i and 0 plus 1i. Okay, when x equal to 0, these are the two solutions, right? And when y equals to minus half, we are getting half minus half I and minus 3 by 2 minus half I. Understood? Here we are getting two pairs. y minus half, this one and this one, this one and this one. Okay. Here we are getting two pairs, this and this and this. Okay, ma, total four solutions you are getting. These four. Agreed?
Yes, sir.
Okay, now we have to just find the magnitude of all four and add. That's it.
Understood, sir.
Clear now? Easy
Clear,
only
sir.
now?
Easy, sir.
Okay, very good. Now this one. This one you need little bit of functions. Okay. Okay, let's try. Here is some complex by some complex. Okay.
Yes, sir.
Okay. Now you are given one hint. Complex real of that complex. This z is actually equal to 3. So that means we can write z as 3 plus iy. Right?
Yes, sir.
Okay. So now 3 plus iy, if you substitute here. Okay.
Yes, sir.
Okay. If you substitute here 3 plus iy, you will get some complex number in terms of y. Only y. Right? There is no other unknown. Right?
Yes, sir.
So for example, this is all in terms of 3 plus iy, 3 minus iy. If you simplify this, multiply with its conjugate, you are getting something. Okay?
Okay, sir.
Okay, this is your z. Okay?
Yes, sir.
Okay. Now real of this is this into this plus this into this. Right? That is this. Right? Denominator is anyway multiplied with its conjugate. Right? Denominator is 8 into 1 plus y square. This is real of z. Okay?
Okay, sir.
Now, real of z, this is actually a quadratic equation by quadratic equation. Agree?
Yes, sir.
This is quadratic equation by quadratic equation. Now, you would have done in IP these kind of questions, right? 3x square plus 4x plus 3 by 7x square plus 10x plus 5. The range of values of this kind of function, right? You remember?
Sir, that one also I felt somewhat tough, sir. Difficult.
Oh, okay. This I think you will get in quadratic equations, no?
Yes, sir.
Okay, so basically this what you do. Okay. The here the idea is to find out what all values it can take. Okay.
Okay, sir.
Okay, we'll revisit that question again. But here is trying to say that. Okay, what all values this can take. This is quadratic by quadratic. Okay.
Okay, sir.
Okay, so if you are able to solve this question, then this is straightforward. Okay.
Yes, sir.
Quadratic by quadratic. Basically, what we do here y into this quadratic 2 equals to quadratic 1. Okay. What we do here. Okay, ma?
Okay, sir.
Okay, so here, then this one will send it to this side. So x square into something of y plus x into something also of y plus some constant minus some y. Okay, equals to 0. You will be able to convert this in this format, no? X square coefficient will be in terms of y. X coefficient also will be in terms of y. Constant also will be in terms of y. Agree?
Yes, sir.
Okay. Now, x, this one, this should be equal to 0, right?
Yes, sir.
Okay. Now, if this is equal to 0, okay, and x is a real number, right?
Yes, sir.
If there is some y, okay, we are assuming this is equals to some y. If this y is a real number, this should be equal to 0, right? Let's say y is 10, then this should be equal to 0. Agreed?
Agreed, sir.
Okay, if this is equal to 0, that means using these coefficients, b square minus 4 ratio should be greater than or equal to 0, right?
Yes, sir.
Agreed. If this y
Agreed.
is real, if y is 4 or 10 whatsoever, then this thing should be equals to 10 times of this thing. That means if you gather x square, x and this thing, then you will get some equation. And that equation should be 0. What does that mean? B square minus 4ac of this equation should be greater than or equal to 0. Right. But B is in terms of y, A is in terms of y, C is in terms of y. Okay. That means this equation b square minus 4ac, you will get a quadratic equation in terms of y. Y square minus 10y plus 14 greater than or equal to 0, something like this. Agree?
Yes, sir.
This part is clear, no? Now,
Clear.
this quadratic equation, it has always has to be 0. What does that mean? This should look something like this. Agree? It cannot
Yes.
look something. It cannot look something like this, right? If it is facing downwards, obviously it should touch x-axis. and somewhere it will become less than 0. Okay?
Yes, sir.
Okay, this quadratic equation y square should always, this quadratic equation should look something like this. Okay, what does that mean? It is always greater than 0. Basically, sorry, this should be greater than 0. What does that mean? It should not have real roots. It should have only complex roots, right?
Yes, sir.
Okay, what does that mean? This again means b square minus 4ac should be less than 0 this time. Agree?
Yes, sir.
Okay, agree, Amma?
Agreed.
This time, using this condition, we will figure out what exactly is the value of y.
Okay, sir.
Okay? Okay.
Okay, sir.
So once you do some example, you will be able to understand. We'll redo this again. Okay. But
Yes, sir.
for now, let's assume that you know how to do that. Okay.
Yes, sir.
Okay. Or otherwise, here it's an easier question wherein we don't have the coefficient of coefficient. We don't have y coefficient, right? Here we have only y square and constant, right? So what is he doing here? Is actually 9 minus y square. He is writing as 10 minus 1 plus y square. He is converting this into 10 by 1 plus y square minus 1. Okay.
Okay, sir.
Okay. So this part, this because this is easy, we are able to do this. Otherwise, that is the general procedure. Okay. Quadratic by quadratic. What is the range of that? Okay.
Yes, sir.
Now, 10 by 1 plus y square. Okay. The denominator is always positive, right?
Yes, sir.
On denominator, this 1 plus y square is always positive, and the lowest value is 1, right? Because y cannot be negative. Y square cannot be negative, right?
Yes, sir.
Okay, and the lowest value is 1. 1 plus y square, it can go up to infinity, right?
Yes, sir.
Okay, so what does that mean? 1 by 1 plus y square. This one, the highest value is 1, and lowest could be 0. Open bracket. Agree?
Sir.
This one, 1 plus y square should lie between 1 and infinity. What will happen to the inverse of this? Reciprocal of this? That should lie between 0 and 1 only, no?
Yes, sir.
1 plus y square is like 1. What are these numbers? These numbers are like starting with 1, 1, 2, 3 up to infinity. If you take inverse, obviously the highest will be 1, right? And these
Yes, sir.
all will be lesser than 1, right? 1 by 100, 1 by 1000, like this. So it would be something like this, right? 1 by 1 plus y square. Agree, ma?
Agreed, sir.
So 10 by 10 plus y, 10 by 1 plus y square should be obviously between 0 and 10, right?
Yes, sir.
Now minus 1 should lie between obviously minus 1 and 9. Okay. This one is between 0 and 10. Minus 1 should be something like this. Agree, Emma?
Yes, sir.
Okay. Now this by 8 should be between minus 1 by 8 and 9 by 8. Agree? Simple.
Yes, sir.
Agreed. Now you know what is alpha, what is beta. Alpha is minus 1 by 8, beta is 9 by 8. And you just need to do this thing. Okay? You should be able to do. Okay, ma?
Okay, sir.
Okay, only little thing here is when you are getting a quadratic equation by quadratic, how exactly to find the range. Okay, that I will tell you again. Okay,
Yes, sir.
see here, this thing, I think we have done this one, no? Or similar one. Sigma of
We
z
did
square.
similar ones.
I think similar one only. Okay, so let's skip this. Okay, z equals to x plus iy. Okay,
Yes, sir.
this satisfies z square plus iz complement iz conjugate equals to 0. Then what is the magnitude of z square?
Sir, we substitute z equal to in z square, sir, and z complement equal to x minus iy, sir.
Okay.
If we, yes, sir.
Okay, try that. So this plus this should be equal to 0. What does that mean? That means both real part should be 0, imaginary part should be 0. Okay. It might get little lengthy, but still you will be able to do. What is z square? Z square should be x square minus y square plus 2xyi, right?
Yes, sir.
Plus I into x minus iy, right? What is the real part? Real part is x square minus y square, and this one, what is this? Minus I square. This is plus y square. This part should be equal to 0 now. Something like this, right?
Yes, sir.
Okay. So, so you can simplify this and figure out what is x, what is y. Okay. Agree? Okay. Try this once.
Yes, sir.
Got it, ma? Pretty straightforward only. I'm getting y as minus half, x as root 3 by 2. So x square plus y square should be equals to 1. Ma?
Hello, sir.
Done.
Yes, sir. Sir, I found the values of x and y, sir.
How much? Root 3 by 2 and 1 by 2 something?
Y equal to minus 1 by 2, sir. X equal
X.
to root 3 by 2, sir.
Very good. Fantastic. Now x square plus y square should be equal to 3 by 4 plus 1 by 4, which is equal to 1. Right? Agree?
Yes, sir.
Mod z square is that only, no? X square plus y square, right?
Uh,
That's it, no?
Sir, 1 minute, sir.
You found your value. You got x equals to root 3 by 2, y equals to minus half, right?
Sir, z equal to x plus iy, sir. So
So z
mod z
square,
equal to
what is mod z? Mod z is root of x square plus y square, right?
yes, sir.
So mod z square is what? X square plus y square, which is 3 by 4 plus 1 by 4, which should be equal to 1, right?
Yes, sir.
Got it now?
Got it, sir.
Okay. Similar problem. Alpha and beta be the sum and product of all non-zero solutions of this equation. Okay. Again, take z as x plus iy. Okay. X minus iy whole square plus, I think this is square root of x square plus y square, right? That
Yes,
should
sir.
be equal to 0. Okay. So that means real part is 0, imaginary part is 0, right? The total is 0, right? What is real part? X square minus y square plus this thing should be equal to 0. And imaginary part xy should be equals to 0. That means either one of them should be 0. Either x equals to 0 or y equals to 0, right?
Yes, sir.
Okay.
Okay, sir.
If x equals to 0, then this becomes y square equals to this thing. Okay.
Yeah.
Or if y
Okay,
equals
sir.
to 0, so if x equals to 0, put x equals to 0 in this equation and figure out what is y. If y equals to 0, again put in this equation and figure out what is x. Okay?
Yes, sir.
Okay, then I think you will get only two roots. Okay, using this. Sum of all non-zero solutions. That means if both are zeros, x and y are zeros, you should ignore them. Okay?
Yes, sir.
Non-zero solutions, you will figure out what exactly are those x plus iys. And then that's it. Okay, I think you are getting plus or minus I only roots. Okay, then sum of the roots should be 0 and product of the roots is actually I into minus I, which is equals to 1. So 4 into 0 plus 1, which is equal to 4. That is the answer. Okay, just try this once. Okay, till this part you are clear now. It is just about solving these two equations and figure out what are the values of x and y that can take. Okay,
Clear, sir.
you can solve it now.
I can solve it, sir.
1 second now. Got this one, huh?
Yes, sir.
Okay. See here. Okay. So A comma B, A plus 5, A comma B are natural numbers in this, right? Look at this. This is a set. Okay. What is the
Yes,
set?
sir.
Set is the pairs of natural numbers A and B, such that A plus 5B equals to 42. Okay. So what are, okay, now tell me what all values are possible. A plus 5B equals to 42.
A equal to 42 minus 5b, sir.
42 minus 5B, right? So you can manually
Uh,
check, right? When B equals to 1, what will happen? B equals to 2, what all values are possible, right?
yes, sir.
Okay, when B equals to 1, 42 minus 5 into 1, right? A is 37. B equals to 2, A is 32, like this. Okay? And B can be up to 8.
Okay.
5 8 is 42, A will be 2 then. Okay? So that's what he is saying. B can be
Yes, sir.
1, 2, 3 up to 8. Similarly, A will be some correspondingly same set. Okay? Some corresponding set. Okay? B can take 8 values. That means obviously A can, this set which has, it has got 8 elements. 8 pairs. Agreed?
Yes,
AB
sir.
is 8 pairs. Okay. B is for corresponding to 1, there should be some A. 2 some A. For 8, some A. Okay. Now what exactly
Okay,
is
sir.
saying? 1 minus I power n factorial. And n is running from 1 to m. That means you are doing the summation up to 8 times, right? 8 minus, what
Yes,
does that
sir.
mean? 8 minus, this means what? This means 8 minus, okay, you can do the summation like this, right? Sigma of 1 minus sigma of I power n factorial, right?
Sir, in next class, can you make me do some sigma problems, sir?
Okay, ma. Sigma you did not do in sequence and series.
Sir, in sequence and series, I am not that good at sigma topics, sir.
Oh, okay, okay, cool, cool. Okay. Okay. So this one, see what exactly we are doing. 1 minus I power n factorial. This one, this 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 set will have eight such combinations, right? 1 minus I
Yes,
power
sir.
1 factorial plus 1 minus I power 2 factorial like this, right? Plus 1 minus I power 3 factorial like this, right? Likewise 8 times, right?
Yes, sir.
Agreed. So I power 1 factorial is 1 minus I. That is this. I power 2 factorial is I square, which is equals to minus 1. That is 1 minus I square, right? This becomes 1 plus I something, right?
Yes, sir.
Similarly, 3 factorial is I power 6, right? I power 6 is how much?
Uh, One,
Minus
sir.
1 again. Okay.
Yes, sir.
After that, it's actually I power 4 factorial, 5 factorial, 6 factorial, whatever. That means I power 4 power something. Right, I power 4 factorial, 5 factorial is all I power 4 multiples, right? Those are
Yes,
all
sir.
definitely ones. So that means beyond 3 factorial, one this all will become 1 minus 1, 1 minus 1, 1 minus 1, right? Remaining 5 ones. Remaining 5 sets are actually 1 minus 1s. That's why all are zeros. Agree?
Yes, sir.
Okay, now it's just about simplifying this. If you simplify this, you'll get 5 minus I. That means you know what is x, you know what is I, and sorry, you know what is y, and you know what is m. M is 8. Okay, straightforward. Agree, Amma?
Yes, sir.
Okay, clear now? Just try to
Y-
finish this and tell me whether you are getting 12 or not. This one,
Okay.
finish this and tell me whether you are getting this answer 12 or not.
Yes, sir. Sir, got it, sir.
Got it, no? Very good.
Yes, sir.
See, next one. This is also similar problem, right? Z1 by Z2, you will convert it as Z3. Okay.
Yes, yes.
And purely imaginary, real will be equal to 0. Cos square theta equals to half. Right. So then you have to find out between minus pi and 2 pi. Right.
Yes, sir.
We'll have to find out angles. Okay. Trigonometric equations. You should be able to do now.
Yes, sir.
Okay. Now here, uh, this is set of some z. Okay. Set of some z. Set of some complex number such that this one is a real number. Right.
Yes, sir.
This is a real number. Right. And
Yes, sir.
and what is saying, and this set has got alpha minus 13 by 11 I. This belongs to this set. Okay.
Okay.
Agreed.
Agreed, sir.
Okay. So we want to figure out what are these z's are. Okay. And these z's are of this format. Okay. Agreed.
Yes, sir.
So z we are writing, this is quadratic by quadratic. That's what we are doing. We are writing it as 1 plus linear by quadratic. This kind of thing. Okay.
Okay, sir.
Okay. Now z is already given. You can do a small simplification like 11z equals to 11 alpha minus 39. Right.
Yes, sir.
Okay. And what he has done, he has multiplied with I again. Why? I multiplied with I because we want this one 11 iz minus 13. Okay. So using this, we got 11 iz minus 13 equals to 11 I alpha. Agreed? Agree,
Yes, sir.
Amma? Okay, so Z becomes 1 plus 11 I alpha by this thing. Okay,
Yes, sir.
agreed. Now this one, okay, so this part should be completely real. Okay, that means this one should be completely real, right?
Yes, sir.
That means this one should be completely real because this is already real. This one should be completely real, right? But this one is equal
Imaginary
to
part
this.
equal to 0.
Right, right. This one is completely real. Agreed?
Yes, sir.
Okay. Now this one is equal to this. That means this is completely real, right?
Yes, sir.
Okay. What does that mean? This one has to be completely imaginary. Then only this I and this I will get cancelled. Understood?
Okay, sir.
This part is clear. The denominator,
Yes.
this one should be completely imaginary only. Okay. Then only that I and this I will get cancelled. Okay.
Okay, sir.
Okay, so now the given condition actually boiled down to this one to be completely imaginary. But Z is of this format. Okay, you substitute this in Z and figure out what exactly is your alpha. That's it. Okay,
Okay.
clear now? Okay, what we
Yes, sir.
have done, we have used this condition to put it here and realize this denominator should be completely imaginary. That's it. Okay, ma?
Yes, sir.
Cool. So what I suggest is, I think you should be able to do these problems. Okay. If you are not able to do, look at the solutions. Okay.
Yes, sir.
Okay. Look at the solutions and try it again. These will be little lengthy, but I think you should be able to pull them off. Okay, ma?
Okay, sir.
Okay. If they are very hard, then fine. Let it be. Okay. I think so.
Okay.
So we have done. I think at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 questions we only have done, right? In this class.
Yes, sir.
14, 15 questions we only have done here. Okay. So similarly, you should be able to do 20, 30 questions. Okay, ma?
Okay, sir.
Okay. So with this, then what will happen? We'll go even faster, right? If you are able to finish them off, if we do 15 questions here and do 30 questions there, then we'll actually get faster. Okay, ma?
Okay, sir.
Okay. Try to do some questions.
Sure, sir.
Okay, ma. Take care then. Bye bye.
Thank you, sir. Bye.
Bye.